Greetings and welcome to my new calculus channel. My name is John Gabriel. So there's been quite a response to my previous video, and so for this reason I would like to give you a bit more of a historical background. So let's begin. Now this particular document that you see in front of you was written by Professor William Dunham. He's an idiot, but that's besides the point, where he talks about how wonderful and great and unbelievable Newton was. And he goes about, using language like only at the end of De Analyse did Newton observe, almost as an afterthought, that an attentive reader would want to see a proof for Rule 1. And that's one of the terms that he uses. Of course, he's thinking about himself and projecting his stupidity onto others. And of course, the things that he says, the kind of terminology he uses are for us mere mortals, and so if you read this here, here's what he says. He says, a modern reader is likely to respond, "Not so fast, Isaac." Actually, he's talking about himself. And of course, he assumes that everybody thinks the way he does. What an idiot. When Newton divided by O, not zero, O, that quantity most certainly was not zero. And a moment later, it was zero. So this, in a nutshell, he says, there in a nutshell lays the rub. And so he carries on and he says, let's see, further down here, this is just his opinion, but just to show you what kind of spectacular fools mainstream academia consists of. So, okay, anyway, I'm not going to go through his garbage. You can read it. But what exactly did Newton say when he talked about Rule 1? Okay, so all he said in the Latin, and this is what he said in the Latin. Okay, I'll tell you now. He said CSI, which means but if y, this part here that you see here, if this is the function, then this is the area, this is the area of the region. Just this formula, not the whole thing, just this formula here, okay? This top formula. So that's all that Newton said. And then he goes about talking about how he uses infinitesimals with this extra block. This here is actually, it's a kludge, it's a prank, it's a crackpot proof. Okay, Newton didn't prove anything. In fact, he proved exactly zero because he assumed that the area function would be given by y, but that's in his assumption because he actually differentiated. And of course, it takes a genius to look through these hand-waving arguments. So, for example, this argument here that he gives with the binomial theorem, this here is exactly the same as that utter garbage that you find in mainstream calculus. It's exactly the same crap. Okay, there's no difference between this and what Newton was doing there, because all he was saying there was this: x plus o minus f of x over o is equal to the limit as o approaches 0 is equal to f prime of x. He stated it as a rule. Okay, now in mathematics there are no rules. Everything has to be proved. Now, Newton used to be my idol. Well, I actually looked up to him because for many years, till the age of 14 actually, and then I realized that something was terribly wrong. At the age of 14, I came across this garbage that you see in front of you here. And it seemed very strange to me because when I looked at the mean value theorem, I thought to myself, wow, why didn't the baboons of the last 200 years define the derivative in terms of the mean value theorem? There's nothing there to do with infinitesimals or limits or any of that other garbage. And that kind of sat in my subconscious for a while until I discovered the new calculus, and I realized that it was impossible to prove the fundamental theorem of calculus without the mean value theorem. And of course, mainstream academics before me did not understand that the mean value theorem is the fundamental theorem of calculus, okay? Because the fundamental theorem is derived in one step from the mean value theorem. If you're not already a subscriber, become a subscriber. Donate at my GoFundMe link. Tell your friends about it. And I'll chat to you soon about something else in the near future, hopefully. My name is John Gabriel.